YouTube viewers, it is Crystal here, and what I wanted to do is I wanted to do a continuation of the video that I previously made, and the reason why is because on the video that I previously made, I said that I was going to put correlation coefficients into the code, but basically what happened is I modified the code in R so much so that I feel that I need to make another video with a code review on it. So we're going to do a Monte Carlo random walk in R, and then so we're going to go over the code for that. I'm using my compiler to do that because my compiler is a free online compiler that allows graphics to run on it, because some of the online R compilers do not allow graphics to run on them, but this one does, and that's why I'm using it. So the first thing that we're going to do is we're going to set our parameters. So the parameter of the steps is in steps is going to be 20, and in simulations is going to be 1. We're going to run only one simulation, and then we're going to do function for a single random walk. So random walk equals function, and it's going to take the in steps as input, and steps equals a sample continuous -1 or 1. Size is in steps, and replace equals true, and position equals cum sum of the steps. So that's cumulative sum of the steps, and then it's going to return the position. So you can see that the functions in R are similar to the functions in Python. And then after we've made our function, then what we're going to do is we're going to run the single walk. So one walk equals random walk, and it's going to take in steps as input, so that's going to be 20 as input. And then after we do our random walk, our one walk, we're going to define the variable mean random, which is the mean of one walk, and var random, which is the variance of one walk. And then so we're going to print the mean of one walk, which is 0.8 in this instance, and print the variance of one walk, which is 2.589 in this instance. So, and then what we're going to do is we're going to find the correlation coefficient. So we're going to set up the lag, which is, I set it up for 2 in this instance. And then we're going to print the lag number. So we're going to print 2. And now we're going to have a function to create a lagged series. And the great thing about this is you do not need to import a library into R to do it. You can do it without a library. So lag series equals function x, comma, lag equals 1. And so C, that's continuous rep in a lag, comma, x, 1 to the length of x minus lag, which is 2. So that's your function to create a lag. So now we generate the lag series, and lagged one walk equals lag series one walk, and it accepts one walk and then lag. So we're going to print one walk, and then we're going to print lagged one walk. So you can see this is our one walk, this is our lagged one walk. So since our lag is 2, the first 2 elements of the array are not applicable because it's not used. Now we're going to compute the autocorrelation for 4 lags. We'll just say, it shouldn't be 4 lags, it should be the defined number of lags, but we'll compute autocorrelation for 4 lags. ACF result equals ACF one walk, comma, lag.max equals 4, plot equals true. So we're going to plot it as well. So we're going to extract the correlation coefficients. So correlation coefficients equals ACF results $ACF. So we're going to display the correlation coefficients for lags 1 to 4, and so it's going to be correlation coefficients 2:5. So these are your 4 correlation coefficients: 0.7959 for lag 1, 0.449 for lag 2, 0.213 for lag 3, and 0.118 for lag 4. So you'll notice that the more lags you have, the lower the correlation coefficient. And so the thing about the correlation coefficient, it'll range anywhere from +1 to -1. So if the correlation coefficient is +1, it means it's perfectly, the coefficient is perfect. The correlation coefficient is perfectly. And then if it's -1, it means that its correlation coefficient is perfectly negative. And if the correlation coefficient is 0, it means that there's no correlation whatsoever. So now what we do is we're going to calculate the correlation coefficient excluding NA values. Correlation coefficient equals core 1 walk, comma, lag 1 walk, and we're going to use complete obs. And so we're going to print the correlation coefficient, which is 0.5187. So we set our lag up as 2, and so 0.5187 is not too far away from 0.449. Now we're going to do the optional plot of the random walk. So we're going to plot the 1 walk type equals L for line, LWD, that's line width, equals 2, call equals blue, main equals 1 walk. And then we're going to put lines on it. So it's going to be brackets, lag 1 walk, comma, LWD equals 2, that's your line width, call equals pink, LTY equals 2, that means it's a dashed line, and main equals lagged 1 walk. So the first thing we've got here, we've got a series of 1 walk, and this is that I didn't show you immediately, but this is the correlation coefficient, or the ACF, of the 4 lags. And you can see here that the more correlation coefficients you have, the lower the lag is. And then let's say if you wanted to do it for 5 lags, I think maybe for 5 or 6 lags, it would actually go negative. But in this instance, it only goes positive. And then so now we're going to do 1 walk. So the color for the 1 walk is blue, and the color for the lagged 1 walk is pink. I hope you can see the pink. It's not very easy to see, but I liked pink, so I chose it. And so this is the chart of your 1 walk and your lagged 1 walk. And so now what we're going to do is, that's your 1 walk and your lagged 1 walk. But what you can do is you can plot the 1 walk, which is what I did, and then you can plot the histogram of the 1 walk. So this is just the 1 walk without the lagged 1 walk, and this is a histogram for the 1 walk as well. So that's it for the R version of the Monte Carlo simulation, Monte Carlo random walk. And so it's close, it's close to Python, but there are some things in R that are done differently in Python. For instance, R, you do not have to import any libraries. But one thing that I did do is I had to ask my good friend Copilot to help me. And so I asked Copilot to help me with the correlation coefficients, or setting up a lagged 1 walk. And it was trying to use a library to do it. And I can't use a library in one compiler. The reason why I can't use a library in the one compiler is probably because it's just a cheap compiler, and they'll let you use R and all of the inbuilt functions in R, but they're not going to allow you to import a library. So I went and asked the question. I said, can you do it without importing a library? And so it did actually do what I wanted it to do, like function to create a lag series without importing a library. So I did have to have help to do this. I asked my good friend Copilot to help me do this, but it was my work. So that's it for the code review. If you liked this video, please like and subscribe. And thank you so much for watching my video. I will be putting this together and putting something on paper or on electronic paper as a code review for this. So thank you again for watching my video. I look forward to making some more videos for you in the future on another technical subject.